Welcome back. We are going to continue 11.2, the series. This is part B of the concept video for section 11.2. So earlier in part A of this video, section video, we learned about geometric series and when it is convergent and when is it divergent. And we also saw about the partial sum and how partial sum, limit of the partial sum determines the sum of the series. So in this example, show that the series sigma 1 through infinity 1 over n times n plus 1 is convergent and find its sum. So if you look at the problem, if you take a closer look at this problem, earlier you have seen only geometric series. You notice that this series that is given is definitely not a geometric series. Because the question is also finding its sum, so it's possible that we have to think along the lines of partial sum. So let's first find out the partial sum. Sn, the sum of n terms, a1 plus a2, a3, and so on up to the nth term. So we can write Sn as sigma I varying from 1 to n, a sub I. We are adding in terms. So it's going to be sigma I varying from 1 to n. So A1, what is AN? AN is without the sigma in the problem. Without the sigma in the problem is AN. So A sub n is n over n plus 1. So A sub I will be obtained by replacing n by I. So it is going to be I over I plus 1. 1 over, sorry. So AN is actually 1 over n times n plus 1. So AI would be 1 over I times I plus 1. It's 1 over I times I plus 1. So now this looks like a partial fraction. So we will focus only on this one here. So it's 1 over I times I plus 1. So it is, if you write this as A over I plus B over I plus 1, then you resolve into partial fraction A times I plus 1, B times I, which is equal to 1. On the left-hand side of the numerator is 1. Right-hand side numerator is A times I plus 1, B times I. So if we use the techniques that we learned in the partial fraction, so if I plug in I equal to, say, 0, I equal to 0, 1 equal to A times 1 plus B times 0, so you get A equal to 1. Then you plug in I equal to any value, at I equal to, let's say, -1. Then 1 equal to A times, if you plug in I equal to -1 in this step, so you get A times 0 plus B times -1, so you get B equal to -1. B equal to -1. So we get 1 over I times I plus 1 equal to A over I plus B over I plus 1. So A equal to 1, so 1 over I minus B equal to -1, -1 over I plus 1. So we have resolved this into partial fractions. Now getting back to this step, S sub n, so this is step 2. So Sn would be sigma I varying from 1 to n. This guy 1 over I times I plus 1 can be written as 1 over I minus 1 over I plus 1. That's what we proved just now. So sigma could be applied for both terms. So if I plug in I equal to 1, well, let's start with I equal to 1. It's 1 over 1 minus 1 over 2. Then I equal to 2. 1 over 2 minus 1 over 3. I equal to 3. 1 over 3 minus 1 over 4. It goes on like this till we get last term 1 over n minus 1 over n plus 1. You notice here, you're only adding, so it's negative 1/2, positive 1/2, negative 1/3, positive 1/3. So all these middle terms are going to get cancelled out. This will also get cancelled out by the previous term. So you are left with only the first term and the last term. 1 over 1 minus 1 over n plus 1. For this reason, so if you have 1 over I times I plus 1, I varying from 1 to n, if you add all of them by using partial fraction method, you're left with only the first term and the last term. For this reason, it is called a telescoping series because the middle terms are getting cancelled out. Now, if I apply the limit as n approaching infinity of Sn on this side equal to limit as n approaching infinity of 1 over 1 minus 1 over n plus 1. The first term is just 1. The denominator is very large, so 1 over that value is infinity plus 1 is infinity. So the whole thing approaches 1, tends to 1. So the limit of the partial sum is equal to 1. So by partial sum method, we know that sum of the series, given series, is S, which is sigma n varying from 1 to infinity 1 over n times n plus 1, which is the given series. That is also equal to limit of the partial sum, which is equal to 1. This type of series is called telescoping series. This video helps. So we will be continuing with this topic in the next part of the video, concept video for 11.2.